The first question in terms of the information that you're given should not be unfamiliar to you. So these are the types of questions that we often asked you in grade 10 and in grade 11. Obviously now, because you should be comfortable with trig anywhere on the Cartesian plane, we can ask you in any of the quadrants. But in terms of the way the question is presented, this is not new. All right, so example one says, if tan theta is equal to 3/4 and theta, sorry, I just want to make this a bit bigger, and theta is an element of 180 to 360, calculate without the use of calculator and with the aid of a diagram the value of. All right, so really importantly, when it says without the use of a calculator, not necessarily, obviously we think of special angles when we think about that. And potentially, yes, there are special angles that you're going to use, but essentially it's asking you to show all you're working out. It doesn't always ask you with the aid of a diagram, but in these types of questions, you should always draw a diagram because it is really, really going to help you. So if we go and have a look at the information we've been given, we were told that tan theta is equal to 3/4. So I'm just going to go over, no, I did not. Just going to go over here. Now remember, tan on your Cartesian plane is y/x. If you think back to what you learned in grade 11, sine on your Cartesian plane is y/your radius. Cos on the Cartesian plane is x/your radius. And when I say x and y, I'm talking about the coordinates because we're on the Cartesian plane. And tan theta is y/x. So what we've been given here is a y value of 3 and an x value of 4. That's the first thing that we know. The second thing that we know is that the tan ratio is positive. How do I know it's positive? We'll just look at the ratio. So tan is positive, which means that if we think about our quadrants, we're either working in quadrant 1 or quadrant 2. We need to obviously decide which quadrant we're working in because that's going to determine whether or not my y value is positive or negative, same with x. This is now where this theta element of 180 to 360 comes in. So theta element of 180 to 360, we eventually get something that works for us, is telling me what range my angle of theta can take on. So 180 to 360 means that I'm essentially working in the last two quadrants, quadrant 2, quadrant 3 and quadrant 4. Now, if tan has to be positive, and if theta has to fall in this range of between 180 and 360, what that means is that I'm looking at a diagram or I'm looking at my Cartesian plane specifically in quadrant 3. Quadrant 3, because tan is positive there, and it falls within my range of between 180 and 360. And this is now where the diagram comes in. Okay, so my diagram, I can go and essentially put the values that I have from my ratio on here. Now remember, tan is a y/x. So essentially, I've got a coordinate here that relates back to the 3/4 I was originally given. And you can almost imagine your right angle triangle if that's more helpful for you. Remembering, of course, that we're working with an angle of theta, and theta or your angle is always measured from your positive x-axis, counter or anti-clockwise. Excuse me. Okay, so your y value is the up-down value. Now, bear in mind, in quadrant 3, y is negative. So this is a -3. In quadrant 3 as well, x is also negative. And so your x or your horizontal side here is -4. Now this makes sense. -3 divided by -4 is positive 3/4. So it makes sense why tan then has a positive ratio here. But we're able to use the information we were given to work out what x and y is. Remember, of course, because you were given x and y, you do actually have a coordinate that you're working with here. You can write it in if you want to. You don't have to. It's completely up to you. Some people prefer the triangle. I personally prefer drawing the triangle and then writing the side lengths next to the appropriate side. It's really up to you, whatever you're more comfortable with. Right, the next thing that we need to remember is that anytime that we're working with our trig ratios, we should have three sides to our triangle. Here we've got x and we've got y. What we are missing is our r value, so our radius. Now, because this is a right angle triangle, I can easily go work out what r is. So r squared, which is the hypotenuse, would be equal to -3 squared plus -4 squared. And this is obviously all because of Pythag. And when you eventually go and work all of that out, you get that r is equal to 5. Now, guys, it is absolutely fine for you to say r is equal to 5 and then put Pythag. You don't have to do all the working out. Pythagoras is a junior level concept, so you don't need to do all the working out and the substitution and the square rooting and all of that stuff. You're welcome to just write r is equal to 5 Pythag. That's okay. So now we've got all three side lengths of my triangle. Now I can go and start to look at the ratios that I've been asked to determine the value of. Okay, so with these questions, there's often a lot of work that you need to do beforehand before you can even start looking at the questions. Drawing your diagram and making sure you have all three sides, working out your third side, which inevitably you have to do, is done using Pythagoras. Okay, so the first question asks us to work out sine 2 theta. Now we need to be really careful here. We were given theta in the question. This is asking me for 2 theta. So that's a bit of a problem. But remember, this is a double angle. And so what that means is we can use our double angle formulae. Angle. And when we've got sine of a double angle, this expands to sine of that half angle times cos of that half angle. And now we're actually working with an angle theta. That's great because remember, my Cartesian plane or my ratio is working with an angle of theta. Okay, so we need 2 sine theta times cos theta. And we can go and read off what sine theta is on my diagram. Now remember, sine theta, as I said earlier, is your y over your r. Because you've got both of those values, you just read them off. So the y value was -3. Your r value, remember, we worked out as 5 because of Pythagoras. Just write that a bit better. And then we can do the same thing for cos. So cos is now x over r. So that would be -4 over 5. Obviously, grade 12s, if you still want to work with opposite hypotenuse adjacent, that's absolutely fine. There's nothing wrong with that. You've drawn the right angle triangle. You're welcome to do that. But it is useful to get into the habit of x, y's, and r's as well on the Cartesian plane. But it really is up to you. And now we just multiply. So this is now where, without the use of a calculator comes in, you now need to show all of your working out. So if I multiply my two brackets, obviously you can do your multiplication in any order. I personally would just do the brackets first. We get 12 over 25. And when you multiply that 2 in, you get 24 over 25. So sine of 2 theta is 24 over 25. Right, so not tricky. Like I said, there's a fair amount of work we have to do before we can get, or before we can start writing down our answer. But once we have that, we're applying the same stuff we've always been applying, our double or our compound angle formula, obviously depending on the question. All right, so if we have a look at the second one, I will make this a bit smaller later for you guys to screenshot. But if we have a look at the second question, we now got cos 2 theta. Again, the angle I was given, or the angle I'm working with, is theta, not 2 theta. So I'm going to have to apply a double angle formula. Now, guys, when deciding which double angle formula to use, it's obviously completely up to you. We know that there's 3 for cos. Because I haven't put them down here, I'm just going to write it. So one is cos squared theta minus sine squared theta. The second is 2 cos squared theta minus 1. And the third is 1 minus 2 sine squared theta. You can pick any one. My advice to you is look at what you have done previously. So in the previous question, I had a sine theta and a cos theta. So actually, I could use any one of these 3 because they only involve sine thetas or cos thetas. Yes, they're being squared, but that's easy enough to do. So pick one that you want to work with. It doesn't really make a difference in this case. If, for example, in the first question, you had only worked with a cos theta, then I would pick the ratio that only has cos theta in it. Otherwise, you're creating more work for yourself. So like I said, it actually doesn't matter which one we pick here in terms of the identity that we need to use. It's completely up to you. whatever you want. I'm going to go for the cos one, but like I said, really doesn't matter. So 2 cos squared theta minus 1. I already know what cos theta is. Remember, in my previous question, I worked out that cos was that -4/5. So I already have that information. I don't need to go and get it again. And that's what I was saying now. Use the information that you have. So this would be 2 cos theta, which is -4/5 squared, minus 1. And now again, it says without a calculator, so you just need to show all of your working out. That bracket squared is 16/25. The bracket multiplied by 2 is 32/25, minus LCD 25/25, which gives you 7/25. Right, so without a calculator in this context, because I don't have any actual angles I'm working with, I'm working with a theta. It's not going to be special angles, but it is asking us to show all of our working out. Right, when it comes to something like tan 2 theta, remember there's no tan double angle identity. There's only sine and cos. But we need to go back to what I said on Monday that says tan 2 theta, we can apply our identity to sine 2 theta divided by cos 2 theta. So remember your tan identity is tan is equal to sine over cos. And like I said on Monday, this can apply to double angles, to angles being squared or ratios being squared. As long as your angles that you're working with are the same, you're good. Now again, we've just worked out what cos 2 theta and sine 2 theta are. In the first question, I worked out what sine 2 theta was, and that was the 24/25. And we've just worked out that cos 2 theta is 7/25. Tip and times. Simplify, and you get 24/7 for tan 2 theta. All right, so really, really not super tricky. It's a case of what formulae do you have at your disposal? What information have you actually already worked out? How can you use it to answer the questions that you have in front of you? Okay. So let's take a screenshot of this. I'm going to have to make that smaller. Right, so there's your first example. Let's take a screenshot, and then you guys are going to try by yourselves. Same idea, use your formula, use what you have in order to answer the question. Okay. Right, so you guys are going to try this question below. I'm going to make it a bit bigger and then put it up for you. Right, so you've been given 3 cos alpha equals √5, and alpha is an element of 180 to 360. Calculate without the use of a calculator, the aid of a diagram, the value of. Now guys, just quickly, you should remember this from grade 10 and grade 11, but you must isolate your ratio. Okay, when I say isolate your ratio, before you can start drawing your diagram, you want to get that cos alpha by itself. So you would have cos alpha, you would have divided both sides by 3. And so you would have cos alpha is equal to square √5/3. This is now your x over r, or your adjacent over hypotenuse. So just always remember to isolate your ratio first if it isn't already isolated before you do anything else. Like I said, you should remember that from last year, but just in case, there's a little reminder. Right, so you've got 3 questions. I'm going to give you 5 minutes, and then we will have a look. Okay, and guys, remember, if you've got questions, feel free to put them on the chat. Feel free to raise your hand, whatever you're comfortable with, but please do ask if you've got questions. Okay, guys, I'm going to give you 1 more minute and then we're going to have a look. Okay, let's have a look. Alrighty, so if we have a look at the first one, so just remember, obviously, what we need to start off with is figuring out our diagram and then working out the missing side length that we won't know. So in this case, because we had cos, we had the x and we had the r. So x was √5, r was 3, and then using Pythagoras, you could work out what your y coordinate was or what your opposite side length was. Now remember, like I said to you, you have to isolate the ratio first in order to figure out what it is that you have going on. So this is my ratio isolated. And from there, and then using the restriction that it had to be 180 or between 180 and 360, which remember is essentially the 2 quadrants 3 and 4. Because cos had to be positive, we're working in quadrant 4. So that's why my diagram here is in quadrant 4. Once you have all of that, you can start answering the questions. Right, and there we go. So very similar to what you already had in the example that we did together, or that I did. And now you are able to go and work out the ratios that you want. I'm just trying to get this all in one go. Okay, there we go. So for the first one, sine 2a, you apply your double angle formulae, and you get -2√5/3. Now, excuse me, we're not super strict about that without a use of a calculator. So if you typed in on your calculator and you went straight to your answer and you left out that step, that is not the end of the world, okay? I've shown you all the steps if you want to know what they are, but it's not the end of the world if you do sort of show your substitution and then do your final answer. Your marks are going to more be for your substitution rather than the actual working out grade 8, grade 9, like tip and times, LCD, that sort of stuff. Okay, for question B, cos 2 theta, again, you can use any of your cos identities, it really doesn't matter, and you're able to get 1/9. And then tan 2 theta, remember, like I said, use your tan identity. You already have sine 2 theta, and you're 2 theta alpha, and you already have cos 2 alpha, which means you can essentially just go divide the 2, and you get -√6/5 in that case. Okay, guys, take your screenshots. Like I said before, if you've got questions, please just ask. Otherwise, we can have a look at our next example. All right, so in our next example, we've got something a bit different here in that I'm now giving you a ratio that deals with a double angle. So in the first example that we did, my angle was theta, or a single angle. This now is saying if sine 2 alpha is √5/3, where 2 alpha is between 90 and 270. Answer the questions. Okay, so Now we actually are working with a double angle. That doesn't change what we do. We're still doing exactly the same thing. It's just important to bear in mind. Okay, so sine of 2a is root 5 over 3, which means according to my Cartesian plane, I've been given y over r. Because I've been given y over r, that means I need to go and work out x using Pythagoras. Again, you're more than welcome to just go straight to your answer. But using Pythagoras, you get a value of 2. Now, we'll discuss that in a second, what that actually means and what sign it should have. You've then been told that your angle 2A falls between 90 and 270. So that basically means we need to ignore quadrant 1 and quadrant 4. We're only looking at quadrants 2 and 3. Sine's ratio is positive, which means we want where the positive sine ratio occurs, which is in quadrant 2. So that's where my diagram is going to end up being. Okay, so take those lines off now because I don't need them. There's my diagram. Remember, what we have is root 5, which is the y value, over r, which is 3, and you've worked out x to be 2. Now remember, in quadrant 2, your x values are negative because it's the negative x-axis. So this actually has to be a negative 2 value. When you got x, what you were actually doing is you were square rooting a value of 4. That has a positive or negative answer. And in this case, we ended up going with x as negative 2 based on where my diagram needed to be on my Cartesian plane. Okay, so we have all of this. We have the missing information that we needed. We're now able to go and answer our questions. Now, this is what I'm saying. You need to be careful and you need to be mindful of what's been asked of you. In the first question, I'm asking for cos 2a. Remember, the angle that you're working with here is 2a. So you're actually just going to go read off that, that ratio. You're not going to apply a double angle in this case because the actual angle that you are working with is already 2a. So cos of 2a, remember, is x over r. You've just worked out x to be negative 2, and r we know is 3 because we were given that. So that's all you need to do here because of the fact that the angle given to you was 2a. Right, the same thing applies then when we get to this tan here. Get rid of this. All right, if we now have considered tan of 2a, the angle is 2a. I just go read it off. Tan, remember, is y over x, which means that tan is root 5 over negative 2. Or you can just say negative root 5 over 2. I don't really mind, which makes no difference. Right, so because in this case, the angles were given as 2a or 2 theta or 2 whatever, you did not need to go and apply double angle formulas. Your angle was already what you wanted it to be. However, when we get to question C, now we need to be careful because in question C, we're now being asked to find the value of sine A. The angle I'm working with is 2a. Okay. And so what that means is now we almost need to go backwards from the double angle to the single angle. And this goes back to the statement I made earlier of think back to what information you have and how you can now use it because you don't want to create more work for yourself at the end of the day. So we have worked out a cos double angle. We worked out tan, but we know that tan has no double angle formulae that it exists in, so we can kind of ignore the tan. So we've got a cos 2a and we've got a sine a. So essentially the question I need to ask myself is how can I incorporate the cos 2a to eventually help me get to the sine a? And so the question is, what cos double angle formulae has a sine in it? Now there's 2 of them. You can decide what you want, but try and go for the one that is going to allow you to get sine easiest. So pick the one that only has sine in it. That would be cos 2a is equal to 1 minus 2 sine squared a. Because remember, we have cos 2a. We know what that value is. So we can go and substitute that in easy peasy. We are then able to manipulate. Remember, I said to you, trig is all about manipulation to get sine a. Yes, you could have used the cos squared a minus sine squared a, but then you have the cos squared that you also have to deal with. And why introduce something else that you need to deal with if you can just get there straight away? So that's why I'm saying always look back at what you have, what you've already worked out, and how it can best serve your purpose. Okay, so we worked out that cos 2a was negative 2 over 3. We already have that value. And now we're going to just manipulate to find sine of a. So the first thing I'm going to do is subtract 1 on both sides. That's going to give me negative 5 over 3 is equal to negative 2 sine squared a. Then I'm going to divide both sides by negative 2, which is going to give me 5 over 6 sine squared a. And then to get rid of that squared, I would square root both sides, leaving with sine a. Right, and that's essentially what we wanted. Remember, we wanted the value of sine a. In order to do that, because we were already given the double angle, we almost had to work backwards with our double angle formulae in order to get the specific single ratio that we wanted. Right, so always remember that the double angle formula works both ways. You can expand and you can simplify, but always look at what information you have. What have you already worked out? How can you use it? Because we already had the 2a, the cos 2a, we wanted to try and find a way to use what we already had found in my working out. Okay. Oh, gosh. Let's take a screenshot here. Sorry, it's been a bit difficult. Okay, I'm gonna have to make that a touch smaller. Right, so there's example 2. Let's take a screenshot. And you guys are going to try one by yourselves again. All right, and remember, Gertals, if you have questions, please ask. This is now where stuff actually starts being really applicable to our exams and stuff, so we need to make sure that we're happy. Okay. Right, so you're going to try these two over here. Let me just make this a bit bigger again. Right, now remember again, you need to first isolate your ratio. So first get alone or first isolate the sine 2 theta. So get that by itself, and then you can start drawing your diagram. And then I want the values of cos 2 theta and then of cos theta. Right, I'm going to give you 5 minutes again, just because you do have to think about the double angle formulae. But let's have a go and let's see what we come up with. Okay, I'm going to give you 1 more minute and then we'll have a look. Again, ask questions if you have any. You're also welcome to put answers in the chat if you want. Alrighty, guys, let's have a look. Okay, so again, please make sure that you do go and isolate your trig ratio, which is what I've done over here. It's a terrible color. So I've isolated the 2 sine theta before I did anything else. And once I had that isolated, I could then determine what my y, my r, and my x were. You did have to go work out your x value. Now, oh gosh, right now, remember, because I have not done, that because it is in quadrant 2, that should be a -8, which means that's -8 over 17 for the first question. And then as we go here for question B, because you've got cos theta, you've already worked out what cos 2 theta is. You can go and use that information to expand. So let's just fix what I have going on here, because obviously I'm just losing a little bit. Right, so you would add 1 on both sides. So you'd have the -8 over 17 plus 1 inverse operations, and you get 9 over 17. From there, you divide both sides by 2, giving you 9 over 34. And then you would square root both sides. You guys, you can either write it as square root 9 over 34, or because you can actually square root 9, if you type it in on a calculator, it gives you 3 root 34 over 34. It just rationalizes the denominator for you, because technically you would have root 9 over root 34, which is 3 over root 34. And we never want to have a square root in the denominator. So to rationalize your denominator, I don't know if you remember this from grade 11, you would essentially go and multiply both numerator and denominator by root 34. Because remember, if you multiply root 34 by root 34, you just end up with 34, because the square roots essentially cancel with the square, and you sort of rationalize your denominator. Again, you can just type it into your calculator. I don't expect you to show the rationalization, but there is a reason why it's happened. All right, so that was my bad. I clearly did it in a rush, but that is essentially how we will answer this or these 2 questions here. So take a screenshot, and then we're going to have a look at an example where we now have letters that we're working with on our Cartesian plane. Alrighty. So if we have a look at example 3, this is a bit different because now, like I said, we have letters that we need to work with on our Cartesian plane. So this first example says, if cos 25 equals k, determine the following in terms of k. So really importantly, in terms of k means that I'm still going to have k in my answer. Even though it doesn't say with the aid of a diagram, I would draw one. So cos 25, that's an acute angle. So you can either draw it on your Cartesian plane in quadrant 1, or you can just draw a triangle. It's really up to you. Okay, apparently not. Let's try. Okay, so either in quadrant 1 or just draw a right angle triangle. It honestly makes no difference. I'm going to sort of do both. So in quadrant 1, you've got that 25-degree angle that you were given. Like I say, right angle triangle. There you go. So we've been told that cos 25 is equal to k. Now remember, that can be written as k over 1 because cos on your Cartesian plane is x over r, or adjacent over hypotenuse, whatever you want. It really doesn't matter. So that means this x value is k and my r value is 1. If I then want to go and find my y value, so this is y, I can use Pythagoras. So y squared would be equal to the square root of 1 minus k squared, which means that y is equal to the square root of 1 minus k squared. And like I say, all due to Pythagoras. You are also more than welcome to go straight to the answer. Just write Pythagoras there. So this side length is 1 minus k squared, Pythagoras. Right, now we have all the information. The only other little bit that I would add on here is third angle of your triangle. You know that you've got a right angle triangle, so you know the 90, you know the 25, and I would just go use sum of angles in a triangle to work out the third angle, which in this case would be 65 degrees. Sometimes they ask it, sometimes they don't, but if you have it there, it then just makes life easier. So the first question is asking me for cos of 155. Now that's obviously not possible. 155 is not in that triangle, so I can't just use the right angle triangle to work out my ratio. So what I now need to start thinking about are my reduction formula, my co-ratio, my double angles, my compound angles, etc. Remember, if it's not an acute angle, the first sort of port of call we go to, unless we can clearly see that it's a double angle with one of the angles I have here. So 65 doubled would be 140, so not quite. 25 doubles 50, not quite. You can see that in B it is. So we're going to have to probably use a reduction here. So if we say cos of 180 minus 25, 180 minus 25 is 155. So we can apply a reduction. 180 minus is quadrant 2, cos is negative in quadrant 2, so we're looking at negative cos 25 degrees. And now because you already know what positive cos 25 is, negative cos 25 is negative k. And this is what we're saying in terms of k. So cos of 155, negative k. Nice and easy, nothing stressful. It's pretty much the same thing as what we're doing already. It's just now with a letter. Right, if we now look at the second question, we have been given cos of 50 degrees. Now again, look out for things like reductions, double angles, etc., etc. And in this case, we can see that if we take the 25 degrees we started with and we double it, we end up with 50. So this cos 50 can actually be broken down into a double angle concerning the 25 degrees. And now we can start applying our double angle formula. Again, makes no difference which one you want to apply. You already know what cos is. So I would go with the reduction that deals with cos, the formula that deals with cos. And so that would be 2 cos squared 25 degrees minus 1, because you already know what cos 25 is. Cos 25, remember, is k. So this would be 2 times k squared minus 1. And so cos 50 is 2k squared minus 1. We've written this in terms of k. All right, so again, always go back to what information do you have? How can you use the information you have to answer your next question and make your life as easy as possible? So don't create more work for yourself. There's no point to that. Look out for your reduction formula, look out for your double angles, all of that sort of stuff. All right, so question C is asking for sine 25. I'm just going to go back up here. So sine 25, we would now actually need to use our diagram. Sine, remember, is y over r. And now we can just essentially go read that off, all opposite over hypotenuse. So the y value was that root 1 minus k squared. Hypotenuse we know is 1. So this would be root 1 minus k squared over 1, which is just root 1 minus k squared. So again, this is why a diagram is so helpful. It looks like a really gross answer, but you've done all the hard work already. You did the Pythagoras at the start. You've done all the calculations that you need to do. There's nothing else that you really need to do here except read it off the diagram. And that's why a diagram is so useful. Alrighty, question D. I'm just going to get rid of some of the space here because that seems a little excessive. This. All right, so question D. Oh, guys, sorry. I've caused my own demise here. Okay. Oh gosh. Okay. So I tried to make life easier and it just ended up making life worse. So we'll just leave it. Okay. Sine of 50. Again, it's a double angle, right? And it's double angle using one of the angles we have. So sine of 2 times 25 degrees will give me sine of 50. Now the sine double angle, obviously there's only one formula for it. So sine 25 times cos 25. And once again, you have all of this information. You've just worked out that sine 25 is root 1 minus k squared. And you know that cos 25 is k. So if you simplify all of this down, it's 2k root 1 minus k squared. Not a very nice looking answer, but also not hard to get to. And the reason it's not hard to get to is because you had all of the information already. You just had to go and substitute in to find what you wanted. Okay, so let's see if we can get this all in. No, because I make it different. Okay. And again, I've made the same mistake. This was an absolute panic station, but there we go. So you guys can screenshot. Stop fiddling. Right, you guys can screenshot this example 3 with all 4 questions there. C and D is here on the side. I'm just gonna put a little arrow there. So there's C and D. I just moved it up so that we can make it a bit bigger and you wouldn't have to look at a tiny little thing. But guys, essentially when it comes to letters, that's really all it is. Okay, you are just using Pythagoras on your Cartesian plane in order to get what you need. Okay, sorry. There was a question, Mashika, is our cos 25 k or negative k? So just be careful. In the original question, cos of 25 is equal to positive k. In the question where we were asked for cos of 155, because of the reduction 180 minus, that's in quadrant 2. So that's where cos is negative. So we're then looking at negative cos 25, so it becomes negative k. So all because of that reduction, I'm now looking at a negative value. Hope that makes sense. Let me know if not. Cool. All right. Okay, so guys, in these last 5 minutes, I want you to have a try of these 4. I'm going to give you 4 of these last 5 minutes, and then I will show the answer. We are going to have to do it quickly though. But let's give this a try. Today is obviously quiz day, so when you're done, you will be able to go and have a look at the quiz on Google Classroom. Actually, great tools, I don't want to rush you. So what I want you to do is take these 4 questions down. And what we will do is we will check this on Monday's lesson. So I will put these answers up on Monday's lesson, but do try give them a try this evening once you've done your quiz. And then, like I say, I'll put the answers up on Monday. I don't really want to rush you with trig. So I'll give you 2 minutes, copy it down. But honestly, excuse me, once you have it down, you're more than welcome to log off. Like I say, quiz on Google Classroom, it'll be up in the next 3 minutes. You're welcome to get started on that and then give these 4 a try. But like I say, once you have it down, if you just want to screenshot it,